So hello students, welcome once again. So see, that's a typical question. I mean the typical question which I was looking for to share it with you people, bacho. Okay, but I got it because see, I had solved such type of question previously also. This time, so somehow I was not getting this question. Okay, so I looked for this question in few books and then I got this question. Okay, so it's a very common question you will find in few books like in different form, but the idea is simple. This is a typical question of method of substitution. Okay, so now the point is that whatever you have within square root, whatever you have within square root, see, normally in method of substitution we have to simplify, because as I always say, we don't have anything called chain rule in integration. Okay, so within square root is in itself a function. So if you have a function within square root, the idea is to substitute it with new variable t. But as we all know, it works only when you find its derivative sitting outside with dx. Normally only then it works, the method of substitution. Here the problem is that if you assume it to be t or t square, whatever you wish, so its derivative will be 8x cubed plus 6x plus nothing but constant. So do we have it outside? Answer is no. Okay, so why I said it's a typical such a question, because it is always based on simple pattern, simple trick, and that is take something common from here. So you have two choices. See, we can of course have x square common, so but I will suggest you to take x common out of the expression which is out of the square root symbol. Okay, so x is power 5 plus x cube plus x. So x into this into square root of 2 times x is power 4 plus 3x square plus 6. See, the whole idea behind this method is that I will be substituting within square root whatever expression finally I get by t, and I should get its derivative outside with dx. Okay, so that's the entire idea. So since I didn't get it in this form, so I need to change this form. I can't reduce its power, because if I reduce its power, you will have something below 6 in denominator. So there is no chance of getting its derivative outside. I can try to increase the power, increase the degree of polynomial you have within square root. So that's why I took x common. Now I will take this x inside the square root. So x is power 5 plus x cube plus x. And we know when we take x within square root, it will go inside as x square. So what we will get, 2 times x is power 6 plus 3 times x is power 4 plus 6x square, and that's it. Okay, we got it. Now all of you can see, now if I assume this, okay, if I replace this 2 times x is power 6 plus 3 times x is power 4 plus 6 times x square by some new variable t and differentiate both the sides, what do we get? 12 times x is power 5. Achha, one more thing. Okay, so you may think, or you may say that how come I know that we need to stop here? The idea is that coefficient of all these three terms is 1. So when you differentiate, you should get the same coefficient. So 12, 3 into 4, 12, 2 into 6, 12. Okay, so that's why I said we are done now. Okay, so 12x5 plus 12 times x cube plus 12 times x, and this is dx is equal to dt. So therefore now I can say this implies our integral is, so if I replace here, if I take 12 common from here, of course if I take 12 common, so this dx is equal to dt. So I'll be replacing this into dx by dt. So what do we get? We get 1 by 12 here, and then this is dt, and then this is root t, isn't that? So that's it. So 1 by 12 into t raised to the power 3 by 2 over 3 by 2. So it is 6 here, so 18. So the answer is 1 by 18 into t, and what was t? T was 2 days. So 2 times x is power 6 plus 3 times x is power 4 plus 6 times x square whole raised to the power 3 by 2 plus c. That's the answer. Okay, so that's again a question which, if you know how to solve it or you have an idea how to approach it, it's a very simple question. So, but you need to know how to approach it. So that's why, as I said in the beginning, I was looking for this type of question from some last few days. Okay, and so the moment I got it in a book, I just picked it up and then I shared it with you people, bachcho.